26, we got a goal line. That's what this G is for. Okay? It's a football field. And somebody's running from the 40 to the goal line, and they're running straight. Okay? So they're running straight to the goal line.
We write this down, right?
Yeah. And they want to know, as they hit the 30, and as they hit the goal line, first of all, are these lines parallel?
No.
Yes, sir.
On the football field?
Yeah.
Yeah.
Okay.
Right? The goal line and the 30-yard line? They're parallel.
They don't have to be right by each other?
No, parallel meaning they never touch.
Oh.
Right?
Okay.
Parallel meaning that even if they went on forever, they would never touch. Does that make sense?
Yeah.
Okay. So then, am I recording? That's a good question. All right. Good. Okay, so they're parallel, right? And then they have this thing called the transversal. Okay? The transversal is the line that cuts two other lines. Okay?
What's it called?
The transversal. And it creates angles. Okay? So it wants you to kind of talk about these angles that are happening here. And it says, describe the two parallel lines and the transversal in the diagram. Okay? And so the runner is the transversal, and the parallel lines are the 30-yard line and the goal line. And so what happens here is that certain angles, because these are parallel, certain angles are going to be what we call congruent. Okay? They're going to be equal, like these two angles. Okay? Let's call this angle 1 and angle 2. They would be congruent. Angle 1 would be congruent to angle 2. Why? Because they're what we call corresponding angles. Okay? They correspond because one's on the exterior of the parallel lines, one's on the interior of the parallel lines. Okay?
Do these run out of ink? I think so.
Huh?
Do these run out of ink?
Yeah, they will run out of ink. Now let's talk about another one. How about 3? Angle 3 and angle 1, those would be congruent, right? Why? What do we call those? We learned that in the first chapter. When they're across. When they're across from each other.
I know.
Reflect.
Cross. They make like a scissor.
External.
What letter do you see?
X.
So exterior?
Exponent.
Not X. Think of the top of this.
Y.
V.
V.
Yeah.
Vertex.
Almost.
Are you asking?
Vertical.
Vertical.
That's.
Vertical angles.
Seeing you're thinking of something else now.
I know. I was thinking of a more complicated word.
I know. Vertical. They're vertical. Right?
Vertical.
They're across from each other. Right? Okay, that's pretty easy, right?
Yeah.
Check this out. What about 2 and 3? Are they going to be congruent? They would be just because of transitive property, right? If we did the symmetric property here and twisted this around, then it would be 2 is congruent to 3 because of transitive, right? But there's more important one than transitive. Angle 2 is congruent to angle 3 because of a new rule we have. You guys haven't seen this yet, but I'm explaining it to you now. And the new rule we have is interior. And they're interior because they're inside the lines. Okay? Interior, and they're called alternate because they alternate around the transversal.
So alternate interior.
Yes. So they would be called alternate interior angles. Okay?
Yeah.
All right. Now, there are some more lines that we could come up with, right? And watch this one. Hey, you know that's equal to, if I call this angle 4, right? You know that's equal to 2, right? Because it's vertical, right?
Yeah.
No.
But did you know it's equal to 1?
Yeah.
No.
Why do you know it's equal to 1?
It's the same thing in a different spot.
Yeah, you know it's equal to 2, and you know that 2 is equal to 1, right?
Flip it around.
Because you can flip it around and say transitive, right? But we have a rule for this one, besides transitive. Okay? We know that angle 1 is congruent to angle 4 because of what we call, now think about this, if this is interior, what are the ones outside of the lines called?
Exterior.
Good, good, okay.
I almost said out.
You guys must be like hella bright or something because I don't know. You guys are getting this so much better than my other 2 periods. It might be the lateness of the day, but they were like tripping on this whole exterior, interior. You guys are getting it, right? So they're exterior. Now, are they alternate or are they on the same side?
Alternate.
Yeah, they're alternate. So what would we call that then?
Alternate exterior.
Duh, right? Yeah, this is the best teaching I've done all day.
Yeah.
I gotta teach like this more often.
That or you just have better listeners.
True story. All right. Now those are all the angles that are congruent, right? Because this one isn't congruent to that guy, right? And this is the same as that guy, right? And this is the same as that guy, right? So those are all the ones that are congruent to each other as far as like
God damn it.
in this group. Now we could do the same thing for the other ones, right? Using the same properties if we labeled them, right? We could say that this was congruent to this because of vertical. We could say that this is congruent to this because they're exterior, they're alternate exterior. We could say that this is congruent to this because it's alternate interior. You see what I'm saying? Does that make sense? All right. So I want to take it to one step further. Is that still recording? Since we're doing so good at this. I want to take it one step further. Did it stop?
Jokes.
Jokes, huh? Always got jokes.
Jokes, cousin.
Makes you look. We're going to take it one step further. Okay? And that step further is, we're going to say, instead of them being congruent, let's talk about them being supplementary. Okay? So, I could call this, what number do you want this? 5?
Sure.
5?
2.
Okay, let's call this 5. We already have 2. We know it's not the same, so we have to put two of those arcs there, right? Okay? So that's angle 3 plus angle 5. How much would that equal?
8. What do? Go down? You subtract?
How much is that?
5. 8.
Come on. Is that a line? How much is a
Oh,
line?
180.
180. Right? Because they're a linear pair, right?
Yeah.
They're a linear pair. Okay? Does that make sense? So they're a linear pair, and we already know that. We know they're a linear pair. But what I'm trying to come up with is, what about 6? Or, no, let's just stick with 5 for right now. Sorry. Let's talk about 5 and 2. What does angle 5 plus angle 2 equal? Now remember, 2 is the same as 3. So shouldn't they both equal 180?
Yeah, but they're not.
They are. And that's our new rule. Our new rule is, what are we going to call that? 5 and 2. Are they interior?
No.
Yes.
Yeah, they are interior.
Yeah, they are interior. Are they alternate?
They're different.
Do they go on both sides?
One's
No. What would we call it if they don't go on both sides? What do you call it when they're on the same side? Right?
they're on the
Same
same
side?
I know that.
Does that make sense? So they're called same. They're called same side interior angles.
Oh, interior.
Right? Same side interior angles add up to be 180. But wait a minute. If it's true for same side interior, do you think it's true for the same side exterior?
Yeah.
Right? So 1 plus angle 6 would equal 180 also, right? Because of what?
Same side exterior.
Same side.
Can I just put SS because I don't got.
Yes, you can. Exterior. And this is where we get lazy, right? And you can go SSE. Right? You could say SSE and angles. And that means the same thing. It's good to be lazy. As long as you're efficient. Right? As long as you get your job done right, you can be lazy. Right? Well, at some jobs. Now, my first few principals didn't like it. Thank God the principal here likes it. They like the fact that I can get students to do well, yet I can be very lazy.
Yeah, jobs for kids, huh?
Right?
And we could be on sales instead of changing for.
But that's probably why tribal school kids like me so much. It's because, we're both lazy.
We like the easy way.
Hey, nothing wrong with the easy way as long as we get the way done, right?
Yeah.
That's what it's about. Believe me, that's why we make cars. That's why we made robots. That's why we did all that stuff. That stuff didn't come because we weren't lazy.
And like the toothbrushes, how they
Brush
spin.
themselves, yeah. Everything. We do it because we don't want to have to put that much work in it. We could dig ditches, or we could build a machine to dig the ditch for us. Right?
Yep.
Or we could just,
Or it could
purchase
make a
slaves.
microwave.
We could get some slaves, right?
Oh, that's.
That's kind of messed up.
Yeah, that's messed
Okay.
up.
All right, we won't do that then. We won't get
We
slaves.
could get some maids and
We
butlers.
won't go back in time. So we'll just make some machines to do it for us.
Let's use the fancy word, maid and butlers.